All right, this is the 5th FRQ from the 2015 BC exam. So they've given us a rational function, and they want us to go ahead and write the equation for the tangent line of the graph. So that's pretty simple. They just kind of told us if there's a number in front of here that this is how the derivative turns out. And then in part A, they told us to put a 3 in that spot for k. So that means f of x is 1 over x squared minus 3x. And they want to have the tangent line at an x value of 4. So 1 over 4 squared minus 3 times 4. 16 minus 12. Okay, so we have the point 4 and 1/4. And then the derivative is 4 minus 2x over x squared minus 4x squared. So we're going to plug in 4. 4 minus 2 times 4. 4 squared minus 3 times 4. So we've got 4 minus 8. And then on the bottom, we've got 16 minus 12, which we already knew was 4. 4 squared is 16. So the slope is negative 1/4. Right? Oh, I did this? When I did this myself, I did the same thing. Instead of putting the 3, because there was a 3 in the problem, I put a 4, because that's what we're plugging in. Let me fix that. 3 in the problem, 3 in the problem, 3 in the problem. Okay, 3 minus 8 is negative 5. Okay, negative 5/16. That is correct. All right, so we've got y minus 1/4 equals negative 5/16 times x minus 4. There is our tangent line. Right, part B. Now they're letting k equal 4, and we have to determine whether there's a relative max, min, or neither, and then justify our answer. So f of x is 1 over x squared minus 4x. F prime of x is 4 minus 2x over x squared minus 4x squared. And so to find the critical numbers, we have to see where f prime equals 0. And that's when the numerator equals 0. Oh, you know what? We don't even have to do that work because they told us already. They said at x equals 2. That was my bad. We just need to do the sign chart. Okay, at x equals 2. So I'm going to pick a number smaller than 2, a number bigger than 2. When I plug it in on the bottom, that's always going to be positive, so I don't need to worry about what happens when I plug in 1 or plug in 3 there. On the top, I've got 4 minus 2 times 1, which is positive. 4 minus 2 times 3 is negative. So we have a relative max at x equals 2 because f prime switches from positive to negative. Okay. Part C. Find the value of k for which f has a critical point at x equals negative 5. So critical values happen when the derivative equals 0 or is undefined. And so I'm going to go ahead and say we're going to figure out where f prime of x equals 0. And so that's going to be where the numerator is 0. And they said at the point when x equals negative 5. So I've got k minus 2 times negative 5 All right. Now, normally I would have seen where the derivative is undefined, and I actually did that. And I said, okay, this is where the function is undefined, and I solved and I got another value for k, and that was not part of the answer key. And I didn't think about it a lot. I just kind of let it go. There's probably a good reason for it. That I can't think of right now. Actually, the reason, well, okay, so here's the reason for it. Let me go ahead, so let me talk through this. So the other value where you can solve for k, so we're saying the derivative is undefined. I'm taking the derivative, I'm plugging -5 in for x, and I end up getting a k value of -5. The reason that this ends up not being an answer is because that means that the original function would have been 1 over x squared minus -5 times x. Never mind. I don't know why. For whatever reason, I was thinking maybe that those would cancel out at an x coordinate of -5, and then it would be 0 on the bottom and be undefined, but it's not. So for whatever reason, they didn't consider this to be a critical point, and I don't know why. I do know where the -10 came from. I just don't know why they didn't consider that one too. Okay. For part D, they said to find the partial fraction decomposition and then use that to integrate. So I went ahead and I factored what we have. So we've got 1 over x squared minus 6x. That's what we're trying to solve. And so that's 1 over x times x minus 6. And so I'll go ahead and multiply everything by that common denominator. So 1 equals a times x minus 6 plus b times x. So if we use x equals 0, then I have 1 equals -6 times a, and then nothing there. So that means that a equals -1/6. If x equals 6, then I have 1 equals, that would 0 out, and I'd get 6b, so b equals 1/6. Okay, so that means okay, so what I went ahead and did is I put the positive 1 first. So I'm going to say that's 1 over x minus 6 minus, because this is the -1, 1 over x. And then since they both had a 1/6, I went ahead and I pulled that out to the front. All right, now neither one of these needs u substitution because it's just x. There's no derivative for that. And so I went ahead and I kept the 1/6 in the front, and then I said ln x minus 6 minus ln x. Make sure I get my plus c. You should be able to leave the problem like this, but you can simplify it. And then you're done.